So in class today during the your first exam review, we did a question on multi-stage growth model. Basically, the question read, the company just paid dividend of 97 cents, and for the next 5 years, the dividend is going to grow at 10.9%, and after that, the company is going to go towards a more stable, constant growth of 5.1% of their dividends. If the return on equity of the required return on equity is 8.9, what should the stock price be today? I did this problem for you guys on paper in class, and now I want to show you how to do it in Excel. So let's first enter all that information. So dividend 0 is 0.97 cents. Growth years 1 through 5 is 10.9%. Actually, 10.9%. And growth years 6 to infinity is going to be 5.1%. And required return on equity is 8.9%. The reason I put this in decimals is because I just need to change formatting. And here this is $1, so I'm gonna put currency. I like that formatting the best, but you can use any of the normal number formattings. You can use number, account name, or currency. Either one that works for you. Okay, so then let's look at the timeline. So if I just grow a timeline here, this is my T and this is my cash flows, my cash flows are gonna be dividends and terminal price. So this is T0, this is time 1, 2, 3, 4, 5, 6, 7, and then infinity. Okay, so what the problem is telling me is between years 1 through 5, the company's income and its dividend is going to grow at 10.9%. After that, it's going to subside and it's going to grow into infinity at around 5.1%. That whole time, the return on equity is 8.9. So what I need to do, if this company had a constant growth, there was no differentials in growth over time, I would be able to just use my dividend at time 1 and calculate my price today. But since this company has multi-stage growth, I need to figure out the first price at the stable growth rates. So I'm only able to calculate that price at time 6, that stable dividend at time 6, so that I can calculate price at time 5. In between then and now, I have to just calculate dividends year over year and then discount them to the present. So how do I calculate that share price? So I have to calculate dividend at time. So let's just call it this way. I have a timeline 1, and this is my dividend. This dividend. Sorry. So the original dividend is 97 cents, right? Then that dividend at time 0 needs to grow times 1 plus the growth rate, right? So I'm gonna lock that cell. Remember, I lock cells by putting $signs in there. This is gonna be my new dividend. If I increase decimal, it's going to be just like what it was on the calculated on paper, what I calculated on paper. Then the next year, my dividend is gonna grow at the same rate. So my prior year dividend 1, is gonna also grow at 1 plus its growth rate, right? I'm gonna lock it. So if I do lock it, I can just drag down the formula, right? So the next month, the next year, or the next period, it can be a month, it can be a year. It just really depends on what the framework of your problem is. So then the next year, the dividend is also going to grow at 10.9%, right? The following year, it's also going to grow at 10.9%. And we are told that that dividend growth is going to stay until around year 5. So I drag down one more time, right? Still, my dividend at time 5 grew at 10.9%. But then at time 6, starting in year 6, that dividend growth is going to subside. So now that dividend or whatever income the company has is going to grow at a new stable level. So that means that it's just into infinity, however long it's going to be, the dividend is going to grow at that level, right? So I can calculate all these dividends, and I can calculate all these dividends and sum them up and discount them to the present and sum them up. But we know that a growing perpetuities formula is whatever your next period's cash flow is. You just need to know that next period's cash flow is what it is. You divide it by the discount rate minus the growth rate. Because if that perpetuity is going to grow at the same rate, you just account for that growth rate. And so what I need is I need that very first dividend at the new growth rate, right? Dividend at time 5 is at the 10.9 growth rate, but dividend at time 6 is already going to be on the new growth rate. So at time 6, I can calculate value of my perpetuity. So, and the value of my perpetuity is price at time 0 equals cash flow at time 1 divided by required rate of return minus growth rate, right? This is the formula that's on your formula sheet. We learned this in chapter 4 on the constant growing perpetuity formula. We learned this in your preferred stock formula. It's all the same concept, and it's the same for valuing the stock price, but valuing a value of one share of stock, its stock price. You need to figure out at which point the company is going to enter a stable growth phase, which is going to be a constant growth phase, right, on average. So if the formula is price at time 0 equals cash flow at time 1 divided by required rate of return lowered by growth rate, that means that I can use my dividend at time 6 to figure out terminal value of my company the year before. So terminal value at time 5. Okay? We are able to do time 5 because this is the tool that we have. The tool that we have is the formula for growing perpetuity. So at time 5, I can use this formula. So my price at time 5 is going to be my dividend at time 6 divided by required rate of return minus growth rate. But be careful. You need to use the new growth rate, that stable growth rate, the constant growth rate. Okay? So this is the price of that stock is 45. And next, and what we need to do next is we simply discount all of these items to the present and sum them up. So price at time 0, price of stock is going to be sum of all of these discounted items. So let's actually calculate present value here and then sum it up. Present value of all of these items. So present value, we don't care about what the dividend that was already paid. This is already priced into the price of the stock. But present value of dividend next year is going to be 1, the dividend divided by 1 plus required rate of return raised to the power of 1, or however many periods you're discounting. 1 plus required return on equity. Next, I have, notice that since I locked my required return on equity, and then let me also raise it to the power of 1, I can just drag my formula down. Let's see, is this correct? So this is going to be 1.19 divided by 1 plus required return on equity raised to the power of 2. And I also need to discount the terminal value to the present value. So I'm going to use the same thing. I'm going to take my 45 divided by 1 plus required return on equity raised to the number of periods I'm discounting. So it's going to be 5. Okay? And now price of my stock is just going to be a sum of these cash flows. And so the price of my stock today should be $34.51, which is the exact same number that we got when we solved it by hand, and what should be in your solutions for your homework. So just to recap, when you are solving a problem with in a multi-stage growth company and you're trying to figure out the price of the stock, you need to figure out all variable cash flows until the company hits its constant growth rate or stable growth rate. And you just calculate the very first dividend that you can calculate using that stable growth rate. And you use that dividend to calculate terminal value. So the terminal value formula is telling us that you can calculate price of a stock a period before the current cash flow, so that if this company's stable growth rate started at year 6, you can calculate price at time 5. Once you have all of these cash flows, you simply discount them to the present and add them up. So if you add them up, notice that the sum is 34.51. I hope that helps. Let me know if you have any questions. Email me, let me know. I'm happy to help. All right, good luck.